You ready? Let's learn some math. Math, 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 math. Math, 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 math. Math, 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 math. Come join me on an adventure. There's so much to explore. Numbers, shapes, and graphs to plot. Solve the problems, connect the dots. Algebra, geometry.
Come, take a journey with us each Monday from 5:30 to 6:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters.
Math, 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 math.
Welcome everyone to another exciting episode of Math Matters. I'm your presenter, Anthony Lennon. Before we begin, let's look back at the challenge question from last week. So the challenge question reads, the following expression represents the area of a rectangle, 169x squared minus 25y squared. Find the length and width in terms of x and y. So let us work this out. Well, we recognize that this expression represents an expression which is the difference of two squares. This is the format. We have a squared minus b squared, and once factorized, we'll get a binomial times its conjugate. In the first bracket, we'll have a plus b, and in the next bracket, we'll have a minus b. So basically, we take the square roots of a squared as well as the square root of b squared, and we'll have a, which is square root of a squared, and b, square root of the b squared. Once we multiply this out, we'll definitely get this back. So let's look at this. We can definitely look at this and see that it's in this format. So let's look at it. We have 169x squared minus 25y squared. We can write this as a square term in terms of 13x to be squared. And we can write this other one here as well as 5y to be squared. So the square of 13x is 169x squared, and the square of 5y is 25y squared. Now we're seeing that this is in this form. So what do? We should have a binomial times its conjugate. So in the first bracket, we'll have the square root of 13x squared, which is going to be 13x, plus the square root of 25y squared, which is 5y. So we're going to have 13x plus 5y. And in the next bracket, we'll have 13x minus 5y. All right, so we have the product of 13x plus 5y and the next quantity, 13x minus 5y. Okay, so we were told that the expression represents the area of a rectangle. So when we have a rectangle, we know the area of a rectangle can be found by multiplying the length by its width. Area equals length times width. And what we have here is the two lengths, or the two measures. We have 13x plus 5y representing one length of a side of the side of the rectangle. On the other quantity, 13x minus 5y represent the other length. Now the addition represents the longer length, the subtraction represents the shorter length. And so we have the length here being 13x plus 5y. That's for the longer side. We call the longer side of the rectangle the length. The shorter side, we call it the width. And so the length now will be 13x. The width, will be 13x minus 5y. All right, so we have both the length and the width in terms of x and y. So when you want to, basically to answer the question, we can write length equal 13x plus 5y and width equal 13x minus 5y. Today, we're diving deep into the fascinating world of quadratic trinomials. Quadratic trinomials, expressions, and equations have helped to shape and enhance modern technology and, by extension, our daily lives. We'll tell you more after these messages.
Join me on an adventure. There's so much to explore. Numbers, shapes, and graphs to plot. Solve the problems, connect the dots. Algebra, geometry.
Come, take a journey with us each Monday from 5:30 to 6:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters.
Welcome back, everyone. Today, we're looking at quadratic trinomials. Now, let's look at some real-life examples of quadratic trinomials.
Payet strikes. Oh, he's in! What a goal! What a goal by Dimitri Payet!
Here we have a typical example of quadratic trinomials in our everyday lives. Football. This player is kicking this football, which will follow a projected path into the goal. That projected path is taking the shape of a parabola or parabola. That parabola can be defined by a quadratic trinomial. We are seeing the greatest ever basketball player, Michael Jordan, shooting this basketball. That ball is taking up the path of a parabola. That parabola can be defined by a quadratic trinomial as well. Quadratic trinomials can also be applied in business. Business owners are able to maximize their profits while minimizing their risk or loss. Even with satellite dish, the shape is defined by a quadratic trinomial. Now let us take a closer look at the inner workings of a quadratic trinomial. Here we have the basic structure of quadratic trinomials. The first term is the quadratic term. The variable x is raised to the power of 2. Hence, we refer to that as a quadratic term. A cannot be equal to 0. If a is equal to 0, then this term will no longer exist and will end up with a linear expression. Now, this term is the linear term. The variable x is raised to the power of 1. Even though we cannot see the power of 1, it is still there. And the last term is what we call the constant term. It has no variable next to it. Let us take a break, and when we come back, we'll look at factorizing quadratic trinomials.
Take a journey with us each Monday from 5:30 to 6:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters.
Welcome back. Now, let us look at factorizing a quadratic trinomial. Factorizing an expression is the same as expressing it as a product of its factors. For instance, let's say we want to factorize 12. Well, 12 can be expressed as a product of its factors. So here we have 12, and we can express it as a product of its factors. 1 times 12 gives us what? 12. 1 and 12 are factors of 12, and when we multiply 1 by 12, we get 12, the product. 2 times 6 as well gives us the product 12. So 2 and 6 are factors of 12. So we're expressing 12 as product of its factors. Same thing goes for the other two factors, 3 and 4. 3 times 4 gives us 12. So when we're asked to factorize 2x squared plus 11x plus 5, which is a quadratic trinomial expression, it means to express it as a product of its factors. Let us look at an example of how to factorize a quadratic trinomial. We have the example, factorize 2x squared plus 11x plus 5. So what we do, we'll need to multiply the quadratic term, 2x squared, by 5. 2x squared times 5 will give us 10x squared. Since 5 times 2 is 10, times x squared will give us 10x squared. Now we're going to express 10 as a product of its factors. So we have 1 times 10, which gives us 10. We have 2 times 5, which also gives us 10. Now, which one of these pair of factors, when added, will give us the middle term, particularly the coefficient 11? Well, 1 plus 10 will give us 11. So what we're going to do, we're going to take the first term, the quadratic term, write it back. I'm going to split the middle term up into two parts. That is the 1 and the 10. Now we have to ensure that we're using 1x with 10x. So 1x plus 10x will give us the middle term 11x, and that we refer to as the sum. And the product of those same two numbers, or terms rather, 1x times 10x will give us 10x squared. So this method is really what people generally refer to as the sum product method. So we're going to take the 1x, write it here. 1x can be written simply as x. And the 10x, write it here as well, and put the constant term down. Notice that we still have the same expression, the same value. All we're doing is splitting the 11x into two parts, x plus 10x, which gives us 11x. Now what we're going to do next is to factorize by grouping. Factorizing by grouping means that we're going to factorize the first two terms, 2x squared plus x. Now what is a common factor of 2x squared plus x? Well, x can be divided into 2x squared and x. So we're going to put x here, which is a common factor. I'm going to divide 2x squared by x. Now when we divide 2x squared by x, this will give us, let's look at it another way, 2x squared can be written as 2x times x divided by x. Dividing x into x will leave us with 2x. So 2x squared divided by x will give us 2x. Next, we're going to divide x by the factor of x, which is going to give us 1. So we have factorized the first two terms. We can always check our answer by multiplying using distributive property. X times 2x gives us 2x squared, and x times 1 gives us back x. Next, we're going to factorize the last two terms as well. The highest common factor of 10x and 5 is 5. 5 can enter 10 as well as 5. So let's put 5 here. Now, we're going to insert brackets. We're going to divide 10x by the factor 5. 10x divided by 5 will give us 2x. 5 and 5 goes once. 5 into 10 goes 2 times. So 2 times x is 2x. We're going to put 2x here. Now we're going to divide the last term by the factor 5 as well. Now 5 divided by 5 is 1. Notice that in this line, we have two terms. We can consider this to be one term, and we can consider this to be another term. What is the highest common factor? Well, if you look at this, well, it's really a monomial, a single term multiplied by a binomial. But if you consider it to be one term, and this monomial, a single term, by a binomial again, if we look at both of them, what is common? Well, 2x plus 1. So what we're going to do, we're going to factor out that 2x plus 1. So if we have x multiplied by 2x plus 1, and we factor out the 2x plus 1, we'll be left back with x. So factoring out 2x plus 1, I should have written this here, dividing x times 2x plus 1 by 2x plus 1 leaves us with x, as noted before. We're going to take this expression here, 5 times 2x plus 1, and divide it by the factor 2x plus 1 again. Let's do that somewhere else. 5 multiplied by 2x plus 1, divided by the common factor of 2x plus 1, and that will leave us with 5. So we'll have 5 here. So notice that what we have in bracket for this part of the expression and this part of the expression, the common factor is 2x plus 1. We took it and factored it out, in other words. And what we have remaining outside of the brackets, x and plus 5. Let's put it in another bracket. But in fact, what we have really done is factor out the 2x. And so this is the solution in terms of factorizing this quadratic trinomial. We have the product of two binomial expressions, 2x plus 1 multiplied by x plus 5. Let us look at the second question. We are asked to factorize 2x squared minus 7x plus 6. Using the same approach, we're going to multiply the quadratic term, that is the 2x squared, by the constant term, which is 6. When we multiply these, 2x squared times 6, we get 12x squared. Now we're going to express 12x squared as product of its factors. Now let's start with 1 times 12. As I said before, we can use 1x times 12x. That will give us 12x squared. Then we have 2 times 6, which will also give us 12. So we can say 2x times 6x, which will give us 12x squared. Let's try 3. 3 times 4 gives us 12. So that's 3x times 4x gives us 12x squared. So all these pairs of factors will give us 12x squared. However, which pair of factors will give us negative 7x? Now you might be asking, how could I add 3x to 4x, or 2x to 6x, or 1x to 12x and get the negative 7x? Well, what we will do, we'll look at the fact that when we multiply two negatives, we'll get a positive. So if we say that we have negative 3x multiplied by negative 4x, we will get a positive 12x squared as well. So in fact, because the middle term is negative, it means that these will have to be negatives. So negative 1 times negative 12, negative 2 times negative 6 will also give us positive 12. Negative 3 times negative 4 give us positive 12. So looking at it, negative 3x times negative 4x give us positive 12x squared. Now when we add these, what would we get? Let's look at it. If I have negative 3 and I add it to negative 4, well, there's a rule. The rule is when you're adding two numbers with the same sign, you want to add the 3 to the 4 in this case and get 7, and you keep the negative sign. So negative 3x plus negative 4x will give us negative 7x. So these are the two factors that we'll use to replace the negative 7x. So we have 2x squared, and we're going to split this up into two parts, the negative 3x and the negative 4x. Again, when you add these, you'll get the negative 7x. When you multiply them, you'll get the same answer as if you would multiply the 2x squared and the positive 6. Okay, so now we have 4 terms. So what we're going to do now, we're going to factorize the first 2 terms. Let's factorize the first 2 terms. Factorizing the first 2 terms, we have x as the common factor. So we're factoring out x from these 2 terms. So we have 2x squared divided by x, and the minus 3x will also divide by x. Now, when we divide the 2x squared, that's this, the first term, by x, what would that give us? 2x squared divided by x. That will leave us with 2x. So we're going to put 2x here. And dividing the negative 3x by x, as I have here, the x's will cancel. Okay, so we'll end up with minus 3. So negative 3x, that's this term, divided by the factor x. The x's will cancel, leaving us with negative 3. We'll put that right here. Okay, so what we're going to do, we're going to look at the last 2 terms. I'm going to factorize them as well. It's also important to note that whatever factor you have as the binomial, the first binomial, you want to make sure that you have it here as well. So some person may just simply put down that factor right away and then decide what term should go here. All right, let's try the approach. What quantity would you multiply by 2x that will give us the negative 4x? Well, 2 times 2 will give us 4. So 2 times 2x will give us 4x. This is a positive, so this has to be a negative. Negative 2 times positive 2x will give us negative 4x. And by the distributive property, when we multiply the negative 2 by negative 3, we'll get the positive 6. So that's one way to look at it. The next step is to factorize this expression that we have here. What's the common factor? Well, the common factor for this quantity over here and this quantity over here is 2x minus 3. Recognize that we have two factors here multiplying, the monomial times the binomial. We have two factors here multiplying as well, the negative 2 and the quantity 2x minus 3. So what factor is common in both expressions? Well, the 2x minus 3. That's a common factor. So we're going to factor out the 2x minus 3. And since it's a binomial, we'll put it in bracket. Then we're going to divide this quantity over here by the common factor 2x minus 3. When we divide the x times 2x minus 3 by the common factor 2x minus 3, we're left with x. So put that in the bracket. Next we're going to do is to divide the next quantity over here, the negative 2 times the 2x minus 3, by the common factor of 2x minus 3. And so the 2x minus 3 will cancel out 2x minus 3, and we're left back with the minus 2. So as we can see, what we have in bracket is the binomial, the 2x minus 3, in both parts of the expression. And what is common? The 2x minus 3. So we take it out of the bracket, so to speak, and put it here. And what we have outside of the bracket, we put it in the bracket, the x minus 2.
Let's learn some math.
Come, take a journey with us each Monday from 5:30 to 6:30 p.m. on ABS TV. Let's get to the heart of the matter.
Welcome back. So now we're looking at solving quadratic equations by factorization. Now remember, we said that once we are solving a quadratic equation, the expression has to be set equal to 0. So when we look at this by examination, we have the 2x squared on the left-hand side. Fine. And on the right-hand side, we don't have 0. We have negative 5x plus 12. So how are we going to get 0 on this side? Well, with equations, what we can do is to remove terms by adding or subtracting. Now, what we're seeing here is a negative 5x. In order for us to remove it, we'll add 5x to this side. Now, once we have negative 5x plus 5x, that will give us 0. Because it's an equation, it has to be balanced. So whatever we do to one side, we want to do to the other side as well. So we are going to add 5x to the other side as well. Let me put that here. All right, so what we have here is the negative 5x being cancelled with positive 5x. And on this side, we'll have 2x squared plus 5x equal, let's write back the constant term, 12. Now, we still do not have 0 on this side. So to get rid of it, because it's a positive 12, we need to use minus 12. Or we can say we subtract 12 to bring that to 0. What we do to one side, we'll also do to the other side as well. So subtracting 12 from 12, this will give us 0 on the right-hand side. On the left-hand side, notice that these are all unlike terms. So we simply write back the 2x squared, the positive 5x, and a constant term, which will be the minus 12. Now we have the expression 2x squared plus 5x minus 12 being equal to 0. So this is the expression being equal to 0. So what we have here is a quadratic equation where we have 0 on one side. It's in the form of ax squared plus bx plus c equal 0, where a is the 2, the b is 5, and the c is the negative 12. Now we tend to use this, especially when we want to solve the quadratic equation by the quadratic formula. However, we won't be doing that. We'll be solving by factorization, the method we learned earlier, which is to multiply the quadratic term by the constant term. So we're going to multiply 2x squared by negative 12. So we're going to factorize the left-hand side, in other words. Let's do that. So 2x squared multiplied by negative 12, the constant term here, this will give us negative 24x squared. Now let's express negative 24x squared as a product of its factors. Let's focus on 24 first. We're going to have 1 multiplied by 24 will give us 24. 2 multiplied by 12 will give us 24 as well. Do we have any more? We have 1, 2, let's try 3. 3 times 8 gives us 24, and 4 times 6 gives us 24. And so we know these are all x terms, since x times x will give us the x squared that we required. Okay, now remember what we said. We're looking for the pair that when added will give us the middle term. And the middle term that we're looking at here is positive 5x. Now because the last term that we have here is negative, it means that one of these terms have to be positive and one has to be negative in order for us to get the negative 24x squared, since positive times positive do not give us negative. So let's see which pair would actually give us the positive 5x. Okay, so since one has to be positive, one has to be negative, we're looking for the pair that when added to give us positive 5x. So that has to be this one, because 3x plus 8x will give us 11x, but if one is negative, one is positive, when added, we'll get the lower number. So let's say we have 3x plus 8x. If the 8x is negative, that will give us negative 5x. Since we want positive 5x, we'll have to put the negative on the 3x. So that's negative 3x plus 8x, and that will give us the positive 5x we're looking for. Remember, when we add two terms, like terms, where one is positive, one is negative, we subtract and keep the sign of the quantity, right, the larger quantity, so to speak. So we're going to keep the sign of the 8x, and that will give us positive 5x. Okay, so we're going to split the middle term into these two parts, the 3x, the negative 3x that is, and the 8x. So we have 2x squared, splitting the positive 5x, we're going to have negative 3x, and the positive 8x, and then the minus 12. So all we have done is to separate the middle term, the linear term, into two parts, negative 3x plus 8x, which still is positive 5x when simplified. Now we're going to factorize by grouping. So let's look at this portion and this portion. Now what's the common factor of the first part, the first two terms here? X. X is the highest common factor of 2x squared and 3x. We're going to insert brackets. Now let's divide the 2x squared by x, and that will give us 2x. Let's divide the negative 3x by x, and that will be negative 3. And let's do the same thing for the last two terms as well. What's the highest common factor? That will be positive 4. 8x divided by 4 will give us 2x, and negative 12 divided by 4 will be negative 3, about equals 0. Now we're going to factorize this portion with this portion. Again, we have two factors here and two factors here. The monomial, the single term, and the binomial, the two-term expression. And we have the monomial and the binomial here, the other two factors. In terms of common factors between this and this pair, what's the highest common factor? What's the common factor? It's the 2x minus 3. So we're going to take out the 2x minus 3 as the common factor. And when we divide this expression here, the x times the 2x minus 3 by 2x minus 3, it will leave us with x. Let's go back over that. X times 2x minus 3 divided by the 2x minus 3. As we can see, since we're multiplying on top, on the bottom we can think of every quantity as a factor of itself. So once we have factors on top and factors below, we can cancel out the common factors, right? So 2x squared, 2x minus 3, correction, divided by 2x minus 3 will give us 1. And so all we're left with is simply x. So dividing this expression by 2x minus 3 gives us x. Dividing this expression here, the 4 times the quantity minus 2x minus 3 by the 2x minus 3, that will give us 4. Okay? So that will be positive 4. Provide the equals 0. Now some person will just simply take the binomial, the 2x minus 3 that we're seeing in both brackets, put it in one bracket, and in the other bracket, the terms outside, in that order, x plus 4, put it in the other bracket. Now we're not finished. We have factorized the left-hand side of the expression, the 2x squared plus 5x minus 12. But we now need to find the value or the values of x because we are solving. When we're solving, we want to find the value of the unknown. Okay, so we need some space here. So let's look at it. Okay, so we have, let's write it on the top, two quantities. We have 2x minus 3 being multiplied by x plus 4. Now you know that when you have two quantities, let's say we have a quantity p times a quantity q gives us 0. What do you think one of those values is? If p times q gives us 0, it means what? Either p is equal to what? 0. Or q is equal to 0. Because 0 times q, let's say p is 0, 0 times q is 0. And if q is 0, then 0 times p is 0. Or both could be 0. So it's the same thing here. We have two quantities that are multiplying. They're binomials multiplying. And so because when they multiply, the result or the product is 0, it means that one of these binomials must be 0. All right, either the 2x minus 3 is 0, so we're going to write that. Either the 2x minus 3 is 0, or the x plus 4 is equal to 0. But let's hold on with the 2x minus 3 equals 0 first off. Now, 2x minus 3 is equal to 0. This will help us to solve for x because we have a linear equation. The highest power we have here is simply 1. The x is raised to the first power. And when that happens, we can simply remove the constant first of all by adding 3 to both sides. And so these will cancel out, leaving us with 2x. And 0 that we have on the right-hand side added to 3 will give us 3. And the next step is to divide both sides by 2. Why? Because 2 multiplies x. The reverse is to divide by 2. Dividing by 2, we'll have x equals 3/2, which can be written as 1 and 1 over 2. Let's take the other one that we said, or x plus 4 equals 0. Now, a quantity plus 4 equals 0. So what we're going to do here, we're going to subtract 4 from both sides to isolate the x. And so we'll have x equals 0 minus 4 will be negative 4. So we have the two values of x. Either x is equal to 1.5 or 3 over 2, or x is equal to negative 4. And so we have solved for x. Now, one way to know if your solution is correct is simply to take the values of x. For instance, 1.5 is 1.5. You can plug it in this equation here, wherever you see x. So 2 times the square of 1.5 plus 5 times 1.5 minus 12, and you should get 0. As well as taking the next value of x, negative 4. So 2 times the square of negative 4 plus 5 times negative 4 minus 12, and that should also be 0. Now let us look at the next question. You're told that the area of a rectangular floor is 45 meters squared, and that one side of the floor is 4 meters longer than the other side. Determine the length and width of the floor. Now, let's say this is the rectangular floor. The length will be the longest side, so let's call that the length, denoted by the letter L. And the width, the shorter side. Now, we're told that one side of the floor is 4 meters longer than the other. Well, the other, therefore, here must be the shorter side, if the other side is 4 meters longer. Now, do we know the measure of the other side? No. So let's take that as x. Let's call this the width here. Let's say that it has a measure of x meters. And since the length is the other side, being 4 meters longer, will be what? The same value x plus 4, since it's 4 meters longer. Now, how do we calculate the area of a rectangle? Well, the area of a rectangle is length times width. And now we'll substitute those values in that we have. the area, we're told, of the rectangular floor is, so that's a key point. Let's go back to the question. You're told that the area of the rectangular floor is 45 meters squared, so we want to put that in. The area is 45 meters squared. Let's leave off the meters for now, meter squared for now. The length we have as an algebraic expression, x plus 4. And the width is x. Now we just don't want to put down times x like that, because if we do, we're saying x plus 4 times x. We'd have to add the 4s. We'd have to multiply 4 by x, then add 4. But we want the quantity x plus 4, which is the length, to be multiplied by the width x. Now, another way of writing that is simply to write the x first and the expression, the binomial expression, x plus 4 after. So we're still multiplying the two quantities. X, one quantity, the monomial, times the two-term expression, the binomial, x plus 4. Now, what do we do next? Well, the next step in this is to multiply out the brackets by using the distributive property. X times x gives us x squared, and x times 4 gives us 4x. Now, when we look at this expression, we're actually seeing a quadratic equation, right? Looking at this part of the equation called an expression, the power on the x is a 2. And so once the power on x is 2, we know it's quadratic. Now, since it's equal to some value, we know it's an equation. Equations where we have two things equal to each other. So we want to basically ensure that the equation is set to 0 in order for us to solve it. Now recall that when you're solving a quadratic equation, that it must be in this form, ax squared plus bx plus c being equal to 0. Now we look at this, we can clearly see that this side, x squared plus 4x, that part of the equation, is equal to 45, right? And so we want it to be equal to 0. It means that we have to subtract 45 from this side, and that will give us 0 on this side of the equation, the right-hand side. And what we do to one side, we want to do to the other side. Now, 45 cannot be subtracted from x squared or positive 4xy, because these are all unlike terms. They have different powers. They are terms in x as well. And the constant can only be added or subtracted to constant. So we have x squared plus 4x plus minus 45. 1 second. Which is equal to 0. Now, how do we solve that? Well, we can use factorization again. So what we're going to do, we're going to look at multiplying the first term, this quadratic term, by the constant term, and this will give us negative 45x squared. Let's express 45 as a product of its factors. We have 1 times 45. What else can we use? We have 2. Can 2 go into 45? No. 3? Sure, 3 can enter 45. 3 times 15 will give us 45. Let's try another one. What about 5? Yes, 5 times 9 gives us 45. But we want the pair of factors that when added or subtracted will give us the middle term, which is the 4x. Okay, now recall that this is actually negative 45x squared. And so one of the terms has to be what? One of the terms has to be positive, while the other must be what? Negative, in order for us to get a negative 45x squared. Now, of course, this will be the pair that we're looking for, the 5 and the 9, because 5 times 9 gives us a 45. Now, if we put the negative on the smaller term and the positive on the larger term, when you multiply these, you'll get negative 45. And when you add these, negative 5 plus positive 9, you'll get positive 4. Okay, so these are the two that we're looking for, negative 5 and positive 9. When multiplied, give us negative 45, and when added, give us positive 4. So what we're going to do, we're going to split the middle term into two parts, into negative 5x and positive 9x. Then write back the last term, which is negative 45, equal to 0. Now, let us factorize this. What quantity can enter both of these? Well, x. X into x squared is x. And x into negative 5x, if we have negative 5x divided by x, that will be negative 5. Similarly, let's factorize the last two terms. 5 can enter 9, well, not 5, but 9 can enter 9x and 45. So let's take out the 9, positive 9. 9 into 9x is x, and 9 into 45, that will be 5. Put back the 0. Now, if we look at this pair of factors here and these pair of factors here, what's the highest, or what's the common factor? That will be x minus 5. And so we're going to factor that out. It should be x minus 5. If we divide this side of the expression, the x times the x minus 5 by x minus 5, the x minus 5 will cancel out, leaving us with x. If we divide this part of the expression by x minus 5, we'll be left back with the plus 9. And this will give us 0. Now solving this, let's see what we'll get here. So we have either x minus 5 is equal to 0 or x plus 9 is equal to 0. Okay, because we have two quantities that multiply to give us 0, it means one of them is 0. So either this quantity is 0 or that quantity is 0. Now if this quantity is equal to 0, it makes it easy for us to solve. Okay, simply add 5 to both sides and we'll get x is equal to negative 5. And if this quantity is equal to 0, the x plus 9, subtracting 9 from both sides, we'll get x equals to negative. One moment, adding 5 to both sides. Okay, this should be positive 5 here. Correction. And this one should be negative 9. Good. All right, so when we look at these two solutions, let's examine these two solutions. Are these both the solutions for this problem? Well, we are told in this case that we decided that we want x to represent the length of the shorter side. And if x is going to be representing the length of the shorter side, x cannot be a negative number. So this one is invalid, because the length of anything cannot be a negative number. So this is the value of x that will be appropriate. So we can say, therefore, that the width itself, the width of this rectangular floor, is equal to 5. That's what the x is, right? So that is 5 meters. And the length is equal to x plus 4, which means equal to 5 plus 4, which is equal to 9. In other words, 9 meters. All right, so determine the length and width of the floor. The width is 5 meters and the length is 9 meters. Let's take a brief commercial break.
Join me on an adventure. There's so much to explore. Numbers, shapes, and crafts apart. Solve the problems, connect the dots. Algebra, geometry.
Come, take a journey with us each Monday from 5:30 to 6:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters.
Welcome back. Thank you for staying with us throughout this episode. Here's our challenge question for week 4. A rectangular garden measures 6 meters in length and 4 meters in width. A border with a uniform width is added around the garden such that the area of the border equals the area of the garden. What is the width of the uniform border? So here we have the uniform border around this rectangular garden. That can help you in understanding this question and coming up with an accurate answer that you will submit to us at email mathmatters268@gmail.com. Once again, we're thankful that you were able to stay with us. Please remember to submit your answers before the Wednesday of seeing the program. So please send your emails to mathmatters268@gmail.com. Please join us next week as I will be presenting you with the topic Relations, Functions, and Graphs. Have a wonderful evening.
Join me on an adventure. There's so much to explore. Numbers, shapes, and graphs to plot. Solve the problems, connect the dots. Algebra, geometry.
Come, take a journey with us each Monday from 5:30 to 6:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters.